All right, hello everyone. Good afternoon, or whatever time you're watching this. Today I'm going to be going over the quiz plus for chapter two. Practice problems on the study guide. So I do have. There it is. So here's the study guide. This is really just a recap of pretty much everything that we have gone over. Um, from the three particles like that make up the atom, the proton, neutron, electron. Um, how to draw the atoms, right? We spent, 2.5 to 3 days on this. So this is something that you're going to have to be doing again on this quiz plus, okay? Um, as I went through it, I made it more and more complicated. I added things like, oh, what happens when the mass is different, right? So you should know if I give you a mass and I give you protons, you should be able to calculate the neutrons. Atomic mass is protons plus neutrons. The charge of the atom is the charge of the protons and the charge of the electrons. Um, so if there are the same amount of protons and electrons, then there is no charge. Right here, protons is what determines an element. Um, and we get back to this point when we start talking about the periodic table, which I have up here. So periodic table, right? 4 at the top here. This means that beryllium has 4 protons, always. That is what defines beryllium. Tungsten will always have 74 protons. The electrons can change, the neutrons can change, but it will always have 74 protons. Okay. This is the answer document. Oh, we're going to get to that. Isotopes, they have the same element, so their protons are the same, but they have different masses. So if you have, going back here, hydrogen. If you have a hydrogen atom that has a mass of 1, that is a different isotope than a hydrogen atom that has a mass of 2. They're both hydrogen, they're the same element, but their mass is different. And you get this by adding the protons and the neutrons. If if the protons are the same, you will get the same amount of mass from the protons. So let's just use hydrogen here as an example. If hydrogen always has 1 proton, so that's 1 proton. If there's 0, try to make a 0 in my hand, 0 neutrons, your mass equals just 1. If you have 2 hydrogen, I should have drawn it like this. I'm going to actually erase this. 1 hydrogen. If you have 2 hydrogen, you have 1 proton and 1 neutron. Gives you a mass of 1 plus 1 is 2. So the only thing that changes is the amount of neutrons. Reset my canvas there. Actually, I probably could have used this stuff here. It's alright. Back to here. Ions is any atom that has a charge at all. This is due to an imbalance between protons and electrons. So similarly, right? Let's take hydrogen again. If you have, I want to do it with, sorry, the pen here. Oh, it only works on Chrome. Okay, interesting. So we're learning how this works alive. This is due to an imbalance between the protons and the electrons. So hydrogen. If you have 1 hydrogen like this, right? There's 0 charge here. That 0 is kind of, we don't say it, but that means that there is no charge. So right here, if hydrogen always has 1 proton, and our charge equals 0, then we have to get 1 times plus 1. This is the charge of a proton. I'm going to put these in parentheses, plus 1, the amount of electrons we're going to need, times minus 1. There's the charge of our electron equals 0. So I'll do an example here about this. So for example, if we go to our periodic table and we go to carbon here. If carbon is 0, my webcam is gone. There I am. Let me pull this over here. If carbon has a 0 charge, it has 6 protons, which gives us a plus 6 charge, and 6 electrons, which gives us a minus 6 charge. Plus 6, you add these two together, you get a 0. Now, if you had a plus 1 charge on this, if you had a carbon with a plus 1 charge, like this, carbon, the amount of protons is still going to be the same. Carbon will still have 6 protons. But now we have to get to plus 1. So 6 minus plus 1 would give us negative 5. And we'd have negative 5, or we'd have 5 electrons. So here's how we get 5 electrons. This is a 5. Alright, so the amount of electrons changes in order for something to become an ion. If we go back over here, positive ion is a cation, negative ion is a anion. So this would be a cation. Okay, so you should be able to calculate the protons, neutrons, and electrons given a charge or mass. So this is really what I've just done right here. If I say that something has a mass of 17 and has 8 protons, so say mass of 17 has 8 protons and it has a charge of minus 2, this is enough information to fill out everything else. So I'm going to make a new here. So we'll do mass of 17. We have charge negative 2. So what I'm going to do probably on your Quiz Plus is I'm going to give you a table like this. I want you to do protons, electrons, and neutrons. And you can see it. Let's just go here. I'm going to make another video on this. I give you basically this, right? Something like this. I'm probably going to give this to you more on the Quiz Plus. I'm just using it as an example right now, but I give it to you here as well, and here as well. And I can also give you the elements. You know what, I'll do that while we're here now. So, if I give you something like this, and I tell you to draw it, right, that goes back to what we have done, and I'm going to get into that, especially in the practice problems, which I'm going to go over in another video. That will definitely go over it. But this is enough information. Actually, this is not enough information. I'm sorry. I said it was 8 protons, correct? Yeah, here we go. So, this is 8 protons, a mass of 17, and a charge of minus 2. So, how would you go about solving this? Well, first, let's see. Element. 8 protons means that the atomic number is 8. So, our atomic number is 8. We know that this is going to be oxygen. First and foremost. Now, our mass is 17. Our protons is equal to 8. So 17 equals 8 plus our neutrons. Make this a plus. So the mass is the protons plus the neutrons. So 17 minus 8 equals our neutrons, which equals 9. So we have a neutron count of 9. Now, electrons. Our charge is negative 2, and this equals the charge of the protons. So protons plus the charge of the electrons. Now we have 8 protons. Each proton has a +1 charge, which gives us a +8. Now I would say plus E. Now to isolate the E, we do -2 minus 8 equals E. So -10 equals E. Now technically each one of these has a -1 charge, so that would give us 10 electrons. Alright, so you're going to have something like this, and the reason I'm giving you this kind of table is to really show what is everything I need to solve for. I'm giving you this information, put that here so you can put, you have a table for yourself. This is the information I have. This is the information I need. Okay? Let's see. Let's keep going on through here. The atomic number, atomic weight, and the atomic symbol of a given element. So if I say I go over here to iridium, 77 is the atomic number. This is how many protons there are. Every element has a different amount of protons, so they have a different atomic number. Here is our atomic symbol. I'm going to get back to that in a second. Here, the 192.22. This is the atomic mass. Our lab during this upcoming week is going to be dealing with atomic mass. It won't be on this Quiz Plus, okay? Like what this actually means. You can identify it, but what this actually represents, we're not going to get into just yet. Atomic number is unique to every element, defined by the number of protons. The atomic symbol is a 1 or 2 letter abbreviation. So let's get into that. If we go back here, every one of these elements has this 1 or 2 letter abbreviation. So iridium is IR. Indium, IN. Oh, excuse me. IRIN. This type of stuff. Now, the first letter is always capitalized. So I'm making the point to really draw this out as a capital I. The second letter is always lowercase. So this is one element. One element. So when I go something like chlorine, this is a Cl. I'm going to draw it like that. This is not Ci. These are not the same. This is chlorine. This is carbon and iodine. Here is carbon over here on the left hand side, and here's iodine, capital I. Okay, I want to make that clear. So when you have something like this is chlorine and chlorine. If you had something that was like this, then you have carbon, iodine, and iodine. Alright? That's what these things are telling us. This is one element, one atom. I'll control the circle, one atom like this. This is 3 different atoms. Alright? Let's go back to our notes here. The subscripts. This is basically what I just had gone over. This tells us that let me create a new one. So, if you have, for example, CH4, this means there is 1 carbon atom, and we can count them 4 hydrogen atoms, like this. So, 1, 2, 3, 4. Okay? Make sure that this number goes down here. It's not like this. It goes up. It goes at the bottom here. Because, as we're going to see, top right is where the ions go. And you can also see this as an example. I had the example where we had something like this. Okay. So there are 2 carbons. So this would be C2 and 1, 2, 3, 4, 5, 6. 6 hydrogens. Now, if we had something that looked like this, looks like this. There's only 1 carbon, 1 hydrogen, so we don't write anything, and then 3 Cls. So this 3 means that there are 3 Cls, 3 chlorine atoms. 1, 2, 3. Again, this is 1 atom, 2 atom, 3 atoms, 4 atoms, and 5 atoms. This is actually chloroform, if you've probably heard of that. Lastly, the notation for an ion. Or not lastly. Sorry about that. So, when we have ion, if we have an ion notation like this means that this is a sulfur atom that has a -2 charge. So, if I gave you, for example, right, protons, neutrons, mass. Oh, I should have put electrons here, but it's a little bit out of order. And charge. And I give you something that looks like this. Our charge is right here. It's -2. The protons, it depends on the element. We find sulfur has 16 as its atomic number, so there are 16 protons. So with this information, we can find out how many electrons there are. So if our -2 equals 16 plus the electrons, it's the same thing we did before, and we should get to 18 electrons. Now, I actually do need to give you more information here, so I'm going to say that the mass here is 32. And from here, we can calculate our neutrons is 32 equals 16 plus neutrons, and we can get to 16 neutrons. Like so. Excuse me. Then if we get to the last thing here, you know how to calculate the amount of electrons. I give you as an, right, notation for isotopes. If I gave you that same thing, but then I told you that I put a 33 up here, now, you know what, I'm actually going to just, oh, I got rid of it all. Great. But now the mass equals 13. Sorry. Ooh, my brain just decided to not work. 33. Mass equals 33. So the mass goes in the top left. You still have the mass and the charge here. This right here is enough information to calculate the protons, the neutrons, the electrons, all that stuff. Because our protons is still going to be 16. Our charge, or our electrons, is still going to be 18. But now I give you the mass, so you can calculate the neutrons. In this case, it would be 17. Okay? One of those charts, like the homework, I'm going to go over that when I do the question review. Right now, I'm really just doing the study guide review. There's going to be a lot more examples, all this kind of stuff here. I'm going to go through this, basically all of this now. So let me finish my recording. You'll be seeing this as, you know, the study guide. Just review. This is going to be for the quiz that's going to be on, or the quiz plus, that will be on Friday. So I will be announcing this during class in school. I'll be posting this all in the Google Classroom. You will see this video. This video will be posted tonight, and then the answer key and the other video will be posted on Tuesday night. All right. So have a great one.